And we are now going to move on to a session which is called Exploring Ultralytics YOLO, Advancements in State-of-the-Art Vision AI. And it is with great excitement that we gather here today to delve into the cutting-edge advancements in vision AI, led by a genuine visionary, excuse the pun, in the field, Glenn Jocher. So Glenn's journey has been nothing short of extraordinary. So he founded Ultralytics, setting out on a mission to pioneer, get this, anti-neutrino analysis efforts for the United States National Geospatial Intelligence Agency. Wow. So this endeavor culminated in the groundbreaking mini time cube experiment and the world's inaugural global anti-neutrino map published in the prestigious journal Nature. So yet Glenn's insatiable curiosity didn't stop at particle physics. It led him to the realm of artificial general intelligence, AGI, a domain where human understanding converges with machine intelligence to explore the profound mysteries that elude us. So in Glenn's eyes, AGI offers humanity the key to transcending the limitations of our own cognition, allowing us to grasp the intricate tapestry of the universe and our place within it. I love that. Very deep. I love it. Today, Glenn is on a relentless pursuit to develop the finest vision AI in the world. For him, this is not just a technological achievement, but a vital stepping stone towards realizing the potential of AGI. These spearheads of this relentless pursuit are none other than YOLOv5, YOLOv8, and the Ultralytics HUB. So without further ado, let's delve into this captivating exploration of Ultralytics YOLO, where you'll witness the future of vision AI forged at the intersection of human ingenuity and technological brilliance. Please give it up for Glenn Jocher. Thank you. Outstanding. I love it, mate. Thank you. Do you need a mic?
Yeah. I think if I could just borrow this mic. Yeah, Oysen, thank you so much for that introduction. That is going to be a tough act to follow. So we've got a few short slides here on YOLO, and I will try and keep it short so we can all get to lunch, since I know everybody's probably hungry. So we're going to talk a little bit about myself, my journey, how I got into the AI space, the state of AI as I see it today, and Ultralytics YOLO, some features, what it does, and the plan for it in the future. Also really important, real world applications, and where we see the roadmap for YOLO and Ultralytics in the next few years. Okay, so I got my start, as Oysen mentioned, in particle physics. I initially worked on anti-neutrino detection on some very mysterious particles. So neutrinos may be the most dominant particle in our universe, and we don't understand them very well. They're all around us, which is a bit frustrating to kind of be in the middle of something that's such a mystery. And I initially came on for data analysis, and so we constructed particle physics detectors as part of a US government program. This was called the Anti-Neutrino Detection Effort. It was led by a few intelligence agencies in the DC area, namely the National Geospatial Intelligence Agency. And what we did is we wanted to create the world's smallest, most advanced neutrino detector, like the size of a soccer ball. And we wanted to use fast electronics and very advanced data analysis to try and get the most information we could from these. The only problem was that once we constructed this, the data analysis turned out to be much more complex than we anticipated. So we got thousands of particles that we didn't want to get, and it was really, really hard trying to find the neutrinos. And I realized that this is essentially a classification problem. We'd get a particle, we'd see scatters of light, and maybe out of every 100,000, one of them would be the one that we wanted, real needle in the haystack kind of problem. And the traditional statistical analysis techniques, fitting, estimation, Newton's method that we were using just weren't completing the task. And so the program was in a bit of danger. And at this point I thought, okay, I need to pull a rabbit out of a hat. I need to do something. There was about 10 or 20 people in the program that were just looking at me on the data analysis side. And if I didn't manage to do something, the program would be canceled. And so I turned to ML. I saw that Google had started using classification in Google Photos. So one day I went there, I realized I could search for a dog and pictures of dogs would come up. This is about, I think, 6-7 years ago. So I was very astonished. I thought, what is this black magic? And I realized it's classification models for computer vision. So I started applying them in the machine learning space. The only problem was that we didn't have any data to train on. So being very good at simulations, I started simulating lots and lots of neutrinos and other types of particles. Yeah, I trained some detectors using just very shallow networks, like 1-layer, 2-layer networks. And the results seemed very good in simulation. And so I thought, okay, this is going to work very well. Perfect. So once I trained my models, I applied them on the real world data. The clock was ticking down towards the end of our period of performance. There's only a few weeks left, and I took all of our data that we collected, several terabytes. I ran them through my new machine learning models, and it was a disaster. It didn't work. And the government shut the program down, and everybody lost their jobs. And so what I discovered was something that's actually fairly common in the machine learning space, was that you see a lot of like really fancy examples out there, textbook examples. Your mind starts thinking, and then you try and apply it, and it just doesn't work well in your use case. So since I'd lost my job, I had a lot of time on my hands. I think Socrates said that let he who wants to move the world first move himself. And that's what I did. I moved myself to Spain. I'm half Spanish. And I spent, the summer of 2018 here in a village in northern Spain working on computer vision, since I thought, okay, particle physics may not be my thing. But I'd seen that the computer vision space was massively more popular. So as Oysen mentioned, we managed to publish in Nature. I think we got about a dozen citations. But I'd seen people in the computer vision space with thousands of citations. And so I thought, okay, this is a much more impactful space and technology, and I can make a bigger impact here also as an individual, because I also noticed that academics publishing papers could have a huge impact. And this is very hard to do in physics. They say that all the low-hanging fruit's been picked. So a long time ago, Newton could have an apple fall on his head and he discovers gravity. And these days, we need billions of dollars, thousands of scientists to really move the needle at all. And so I really found my stride in computer vision. And so I spent the entire summer studying YOLO models, which were the latest and the greatest. So I didn't invent them. There's a guy called Joseph Redman. Him and an academic advisor called Ali Farhadi created the first few models, YOLOv1, 2, and 3. And then they parted ways for different reasons. Joseph thought that the YOLO models were advancing so fast that he was worried they might be used for military applications. And he was partially correct. And so he thought the best way to avoid that possibility was simply to stop working on them. And so he just went into teaching instead. Ollie had the opposite idea. He created a startup. It's called Exnor. He sold it to Apple for a lot of money, and I think he's still there. And so this meant that there was nobody working on YOLO anymore. But luckily enough, they'd open sourced all their work. Unluckily enough, though, it was all written in C and C++. And so I had a big job trying to figure out what was going on there and port it over to a language that was a little more readable, which is Python. And so I did a lot of things I'd never done before. I open sourced all my work. I started learning Python, which I'd never used before. And I started doing AI and entering competitions. And so as luck would have it, there was a competition that came out that summer, and I tried my hand at it with YOLO models, and I did not do very good. But I created an open source repository, and this is the first time I started getting this feedback cycle of users commenting on my work, pointing out things I could do better, and so on. And so this was 2018, which is kind of like right in this curve here. And I just managed to get interested in this space just at the right time. And so there was a lot of change going on, not just in the algorithms, but in the hardware. And as I mentioned before, ML is actually nothing new in theory. It's been around since the 1960s as a concept, so 60 years almost. And nobody's really been able to realize that vision and kind of execute on that due to limitations in the hardware. But thankfully, the hardware had caught up about 10 years ago, and you could suddenly use a consumer GPU. You could train the latest models. And I really liked this because this meant that just an individual could come up, buy a GPU, plug it in, and start playing and start experimenting. And I always learned by example. And so this was really amazing for me. So unfortunately, in the previous slide, we see that chart keep going up, though. And this is exploding model complexity. And what's happening is that obviously as a model gets more large, you need more resources to run it. And just as, say, 20 years ago, the average ML model, the kind of like leading edge in research and development was out of reach of the average person, we seem to be finding ourselves kind of trending in a similar direction, where the latest LLMs are impossible to train by yourself and impossible to research with unless you're a very large entity with significant resources. And so this is a bit of an unfortunate trend as I see it. It means that a lot of the R&D is going to be concentrated. And I think it kind of leaves a lot of the population like out of reach of developing their own solutions, using them definitely. But I think playing around and exploring solutions is one of the key advancements that the community's made in the last decade. So what makes me really happy though is YOLO is the antithesis of this. YOLO models are very small, they're very fast, you can train them yourselves. It could only take a few hours to a few days. If you're paying for cloud time, it might only be a few dollars or a few euros. So that makes me really happy. This means that like what we're making is broadly accessible. You don't need to be a special person. It's not an expensive sport, and everybody can have an impact. So just like I did when I came in, I didn't go to school for ML. I didn't have a strong background in industry with it. Just an interest and a passion, and I think anybody else can sort of like pick up that torch and carry on from there also. So. Okay, on the next slide, we've come a long way since those early days just a few years ago. So after the competition I entered, I created YOLOv5 for satellite imagery. It was called YOLOv5 XView. And I thought, okay, this didn't work well. I've learned a lot of things though, and I want something more general. And so I just went about creating a general YOLOv5 repository. And then I kept improving it. And then eventually I realized I should probably launch a new architecture. And so I did that 3 years ago, May 2020, and this was YOLOv5. So we received a bit of criticism. There was some controversy, mainly because we weren't connected directly to the original authors of the paper. And I tried to address a bit of it at first, but eventually I sort of just kept my head down and kept working, which was what I was best at. And I would, most importantly, integrate feedback. So I had a lot of conversations with users. So in the last few years, I've had over 10,000 conversations that are all out there, all public on GitHub. And I'm not really a good listener usually, but I see what people say. And after enough people complain about something, I fix it. And I would do it very fast. Since I kind of had this like personal approach to everything, when something broke, I took it personally and I was like, oh no, oh my God. So I'd fix every bug as fast as I could, like often within like a few minutes or a few hours when someone submitted a bug report. So this meant that the YOLO models that we had were iterated thousands and thousands of times. So I think if you go to YOLOv5, I think there's about 3,000 pull requests there. And each of these is, of course, like introducing a feature, fixing a bug. And if you make something better every day, after several years, you're going to end up with something amazing, regardless of whatever field you're in. So these days, we're really lucky here. The community also really kind of converged around our efforts. And with hundreds of contributors, we've really picked up just so many impressive analytics here. So we've gotten 60,000 GitHub stars in the last few years. We have millions of monthly visits to our repositories, and we've been able to track some analytics for usage with our Ultralytics Python package, and we can see that people are, on really busy days, training up to 100,000 YOLOv8 models. And on a really slow day, it might be something like 20,000. So the usage is just unbelievable. And it's really humbling to be able to create such a product and have such an impact that's felt around the world. So on the next slide. Okay, so the advancements that we typically like to hear about are things like quantifiable numbers, like the memory increased by this, the speed is like 10% faster. But in reality, we've taken a completely different approach to product development. And what I've done is I've started from the person that's going to use the product. And I think this is a good strategy regardless of the space you're in. But in ML, the person is going to be interacting with your model. And we want to make their life as easy as possible. I think Callan said something funny, and it's kind of ironic because in reality, there's a lot of complication behind it. But what we want to do is present a very simple interface. And so with YOLOv8, we started just with a blank slate with a first principles approach. And we said, what could we do if we could do anything? How would we create like the front end of the product? And there's still an issue up there on YOLOv8, which I think is from maybe like last fall, before the repo went public. And I created this, and I just imagined I was using it, even though it didn't exist. And I said, how do I want to use it? And I'm pretending I'm an average person, like a user creating a product. And So I looked at this and I just sat on it for like a month. And then, every day I would look at it and I'd tweak a line here, like go to sleep and have like a weird dream about YOLO. And after about a month, I had something that was pretty refined. And I thought this is sort of like the optimal usage for a YOLO model. And so that's what we ended up creating. We worked backwards from that front end. And then we went back to the technology, which is, of course, is really important too. We had a bunch of advancements that we curated from around the field. So what happened was with YOLOv5, the first year, 2020, I worked on improving the metrics, the accuracy, the speed, and I was trying to get it up to the state of the art. And the second year, 2021, was the same thing. And then 2022, I kind of fell back on that and I started implementing more tasks, more ways people could export to different formats, writing a few more tutorials. And this left a bit of gap open up between like the leading edge research and where YOLOv5 sat. And so this allowed some other groups to come in and launch competing models. And they did a pretty good job of that. And so Meiton came in with the YOLOv6 model, which is fairly impressive. And then Alexi came back with Wong Kin-yu, who's in, I think, South Korea. And they launched the YOLOv7 version, which included elements of YOLOv5 plus some additional advancements. And this is actually great. So like, I'm always excited when this happens because it means that there's room for improvement. So anytime you lose at something or somebody beats you, it's exciting because it means that there's something you could have done better. And so we reviewed all this research and we implemented the best elements of each architecture that we could find into YOLOv8 here on the technology side. And then we tried to connect the dots. So the user front end with the technology on the back. And we ended up with a few very simple and important concepts. So simple usage above all, this is the most important thing. Well-documented workflow. So this is a huge failure mode that I had with YOLOv5. I was so busy just writing code that I didn't document it and nobody was aware of some of the features. And if they had questions, it was difficult to try and understand. And so this is because I came from an engineering background rather than a software development background. And so I learned a lot of things and now YOLOv8 is much better documented. We have about 200 pages at docs.ultralytics.com. They explain how to do everything. They even have YouTube videos that kind of show you and walk you through it. So we've listened to the community and we try to do a much better job there. But even that is still a work in progress and we really want to improve it. So code also, spotless code. YOLOv5 was a bit of Glenn code. And I've taken a much better best practices approach now. I've kind of like reviewed and taken to heart a lot of the feedback. And so the code inside YOLOv8 is now much more best practices. It's similar to what you'll see in packages like TensorFlow and PyTorch. And flexible solutions. So YOLOv5 started just as an object detector, which is a real sweet spot in the computer vision space. It probably has about maybe 70% or more of the market share. And so this means that if like 100 people are deploying models, maybe 70 or 80% of these use cases are just object detection use cases. So just by coincidence, it was a great place to start. I didn't know that when I started. I probably should have started with classification because that would have been much simpler. But I started with object detection, and by coincidence, that seemed to be the right choice. But that doesn't solve every problem. And so now we also support additional tasks, classification, segmentation, pose, tracking, re-ID a little bit, and many other exciting things. Oh yeah, here's a great graphic. And we don't just support these tasks, we've made it seamless to kind of switch from one to another. So we offer pre-trained models on all of these. For detection, we offer Coco and Open Images v7 pre-trained models. And for the rest of the tasks, we do Coco, and for classification, ImageNet. And the exciting thing, though, is that the interface for all of these is the same. When you load one of our pose models, for example, it's the same as loading a detection model. And when you run inference, the commands are the same. And when you get the results, the format is the same. And so this means that if you're running YOLOv8 for detection, it's going to be very easy for you to evaluate pose. And so the question that we had earlier about what's important when evaluating models, and this is really why I feel that simplicity above all is the most important thing. If you can lower the barrier to entry, more people will walk in, and more people walking in means more potential contributors on GitHub, which makes me excited because it means more potential improvements. And there's also a lot of tasks that are missing here. I guess there's a long tail of tasks that we're trying to chip away at bit by bit. As I mentioned before, depth, I think, is an interesting one. Also just RGBD data for depth. In robotics applications, this is really common. And we really want to, I think, train some data sets and make pre-trained models available there also. Beyond that, action recognition is often requested. And I think that's something that we're going to work on also. Fatih's taking the lead on that. And we should have something out either later this year or early next year. So this will be really useful, for example, for like retail applications, for shoplifting. Maybe your pet is doing something and you want to like grab a screenshot and show them and be like what'd you do? So, but we've got some really, really cool real world applications here. So when I started working on YOLO, it was just all kind of like theory. I was just doing my own thing. And as more and more companies started coming forward, asking for solutions, asking for help, I really started to interact more with the community, more with the people that were actually using the product. And so we don't have any company names here, but we've got, and the reason for that is just simple privacy concerns. I think next year we're probably going to have like a few like real highlighted use cases that we can show. But the first one here is healthcare. So we have a major healthcare provider in Europe who's using YOLO for a variety of healthcare needs. So on the manufacturing side, for flaw detection, and also within hospitals, for example, for automated scans or to assist medical professionals in better evaluating kind of the visual output of CAT scans, X-rays, and so on. In agriculture, I've learned a lot of things also. So we have a major public company in the United States who's deploying YOLO to industrial farms and also smaller farms. And what they do is livestock tracking. And there's a lot of interesting things. So they want to track animals throughout the course of the day. They want to make sure they're eating. They want to see how often they're drinking water. And they can also, just through animal pose estimation, see how healthy the animal is. For example, if a cow does not raise his head above the horizon, it's an indicator that he may be sick. And if you can track that individual cow, then you can send a veterinarian right there. And this is actual, like, real world cost savings in case of a sick animal. So one of the funny things about that is re-identification of cows. So it turns out there's facial recognition for cows. And this company is kind of like, so since we don't offer facial recognition yet, they're integrating a third-party cow facial recognition into the YOLOv8 tracker system. And this way, when they have a drop track and they're trying to reacquire, they can do facial recognition on all the rest of the animals and pick up the right one. So, and lastly, there's retail examples and there's also shipping examples. So chances are, if you're getting a package delivered in the mail later this year, next year, YOLOv8 is probably watching that to make sure that it gets to its destination, that it's not damaged, and so on. So this is really exciting. Also, we have a major retailer, a supermarket, which is rolling out YOLO for self-checkout systems. And I think by the end of this year, early next year, it should be in thousands of self-checkout systems starting in a country here in Europe. And so this is just real exciting for me because I guess the ideas that I worked on originally are actually making it out into the world. This is something I could never realize in the particle physics space and something that's actually happening now. So, okay, so the general trend here. So we've done a few interesting things also. So Ultralytics has had a winding journey. And so in the last few years, when I first started working on YOLO, I was initially just by myself. I didn't have any revenue, no clients, no customers. And it was more of kind of like a passion, more of a bit of a hobby. And my principal motivation for it was to, I guess, more equitably spread the potential for AI across the population. So when I got in, I saw that there's a lot of academic research. I saw a lot of people were doing a lot of work in AI, and then just putting it out on GitHub. And then I saw that there was a lot of large enterprises who would look at that, kind of wrap it in a shiny package and maybe host it in a cloud and charge a lot of money for it. And I thought this didn't seem right. There seemed to be kind of like a gap in the middle. And I think also, like, for like where a lot of the enterprises were charging for, maybe I could just give away for free. And that was kind of like my initial approach. And I think it worked really well. And so YOLO became widely adopted. And even after like about 2 years, so even after like a year after I released YOLOv5, I still hadn't monetized, and it wasn't a big concern of mine. I think that's also one of the reasons that it's become so popular, because I didn't have this overhang, a requirement to make money from YOLO. I was just essentially doing it just for the competition approach, and for, I think, my own ethical approach to try and put out the technology and just give it to everybody, put it in their hands. But of course, to expand upon that, as Oysen so wisely said, you can move very fast yourself, which I did for the first couple of years, but you're not going to get very far all by yourself. So one of the things I noticed was that when I launched YOLO, I also wanted to create an app, and I had no idea how to make an app, but I did it anyways. It took me like 6 months. It was a horrible time. And it was this iOS app. And once I'd launched it, I think like the next day, the first user from the first comment was, "Glenn, this is great. Can you make an Android version?" And I thought, oh my God. I was like, no, this is not right. I need to probably just focus on what I'm good at and just bring in some people for the other parts of the business. And so I made my first hire. I was here in Madrid. I'm half Spanish, and so I had some family. And so since I was here, I tried to find a mobile developer, and that turned out to be Sergio here in the back row. And he came on to start helping with the other parts. And then from there, I started adding some more people. So I brought on Callan to try and make a web product, since I'm not very good at web either. And from there, like a few more folks to let people know about YOLO on the marketing side, to try and get us into shape on the branding side, and also to try and start generating some revenue so that we could be self-sufficient. And I think we've done a pretty good job of that, but I think the trajectory for the company will always be a parallel trajectory where we're creating open source products for free that we want the entire world to use, and monetizing them for large enterprises that have the funds to pay for them and are probably already paying a lot more for other products. So Hub is a key part of that. So we want to make everything easy. And right now, Hub has a lot of users, and they're mostly using it for free, which is real exciting. So they're training models, they're deploying them, and we also want to give them value-added features that we can charge a little bit of money for. But by and large, the main way that we've managed to succeed in the business side is simply through licensing. So YOLO is opened up as an AGPL code, which means everybody can use it for any purpose, even commercial, as long as you also open source your work. And the main reason for this is that we'd like to keep the research open. So if you make a big improvement in YOLO, it'd be great if we could come see what you did and then bake it back in and then release that for everybody. So this way we keep improving the field as a community. And of course, for organizations that would rather develop in private, we have an alternate license, an enterprise license that they can buy, and that lets them embed YOLO in any products and keep those private. So later this year, well, today actually, that's right, we're launching Hub Pro. So Pro is, it starts at $20 a month. It gives you a few extra goodies like Halen mentioned. And we're gonna add cloud training, cloud deployment, and all this stuff also to it. So this is really exciting because we're very tightly integrated. So the main people that are creating YOLO are now creating Hub, and I think we're best placed to kind of create this SaaS tool and to create this no-code solution for YOLO models. There's a lot of them out there, obviously, though, and we do a good job of engaging with all those companies, making sure those platforms can also offer YOLO models. So we're launching Hub Enterprise next year, and this is really geared towards larger companies, and it's going to come bundled nicely with enterprise licenses and so on. Gives enterprise goodies like on-premise solutions and so on, SLAs, and then off into the future, right? This is really one of the main questions. I got asked the other day, like where I see myself in 5 years or 10 years, and the honest answer is that it's very hard to tell. 5 years ago, I'd never done AI, so if somebody asked me then where I saw myself in 5 years, my response would be essentially meaningless. But this is kind of exciting. So like we have a near-term roadmap, but beyond about 24 months, we have to see the situation as it evolves. And I think this is the exciting part about the field that we're all in. Nobody can say for sure which direction it's going to go or where we're going to be, say in 12, 24 months. For some people, I think that caused a bit of worry, but for me, it caused excitement. I wake up every day kind of excited to see what the users are saying, what the latest advances are, and just to get to work. My desk is like a meter from my bed, so sometimes I just roll out of bed and start working. So I think there's a bright future, and I'm really excited for the potential. And also, I think for all the evolving use cases the companies that are using the technology in the space, and just like the amazing feedback that we hear from everybody. So.
Okay, mic number 2 is on. Right. Do we have questions? We must have questions online, questions in the room. I found that to be very inspiring. I think that's just brilliant. It's a real kind of view into the innovator's mindset and the kind of thing that drives you to make these huge technological leaps of faith and leaps of collective faith as well. It's quite extraordinary. So it was great to get a kind of flavor of what actually were some of the ingredients in there. And, Phil, I was kind of with you there when you kind of were like, yay, you launched an iOS app. And the first comment is like, oh, it's not on Android, but which is, a valid comment, but, perhaps not what you want to see on the morning of the launch. Do we have any questions or any reflections there? Did anybody else feel the pain? Talia, up at the back there with the mic. DJ Talia, have you got any questions from our amazing community online?
So, yes, the first one is, will it be possible to get segments and poses at once, or will this require a new model that has the output nodes for both?
Yeah, this is a great question. Ideally, we want to trend towards a solution that has a common input processing and a common backbone, even a common neck, and then simply splits off into different heads, which you might even be able to detach should you not need. So this is similar to what Andrew Karpathy was calling a Hydra network when he was at Tesla. This would be something that kind of recycles a lot of the operations that are going on in the backbone, but something that's also trained on multiple tasks at the same time. So I think being exposed to more data would make this a more robust network. But at the same time, it would be slightly overkill if your task is minimized. And so you see this kind of strange effect where the more capable the model, the larger the inference burden and the larger the annotation and training burden. And so that appeals in some use cases, but for other use cases that are just extremely targeted, that need, say, millions of images processed per hour, they would kind of opt for something just much more narrowly scoped. But yes, we definitely want to have that option, at least for the people that want that. One of the challenges that we're facing right now is all of our tasks have the same pre-processing, they have the same backbone, they have the same neck, and so this is actually not too far away. Classification is the holdout. It has a different pre-processing pipeline, which is center crop. It performs better that way, slightly better. And so I think if we can just merge the pre-processing and then create a loss function in a data loader that can handle the different types of tasks, which is not trivial, maybe even visualization scripts. So it's definitely doable, and I think it's in the roadmap. So it's something exciting that I think we could launch.
What a fantastic question. Thank you, Talia. What else have we got?
So next we have, is YOLOv5 still the market leader compared to YOLOv8?
Yeah, so when I first started working on AI, I was simply trying to replicate the leaders in the field. I'd see these other architectures and they seemed very far away. And I thought, okay, if I could just kind of get a little closer, learn from them and so on. And so once I launched V5, the improvements I kept making to it, and something really important is that V5 wasn't a single launch. It happened on one day, but then I just got back to work right after and I just kept improving it. And so V5, V8, they change almost on a daily basis in small ways, but small things accumulate over time. And so when we launched V8, I thought maybe everybody would just run over to V8 from V5 like in a few weeks or something like that, but that did not happen. So no. So V5 still has the majority of the traffic it had in January when before we launched YOLOv8. And so I think what happened is two things. I think first of all, like it's working well enough that people aren't like desperately looking for an alternative. And the second thing is simply that I think as you embed something into a product, it's a little hard to replace it. So edge devices and edge models are sort of unique in this sense. If, for example, YOLOv5 was just an API, you just pinged it on the web, and then we release a YOLOv8 API, I feel the transition would be simpler for everybody. But I think due to the edge nature of a lot of computer vision models, that's not the case. And so for people that had V5 deployed in solutions and so on, I think it's not trivial. And you'd have to justify that in a commercial sense to your boss. You have to say, listen, I need this budget to do all this research and take this out and put this in. And they're going to say something like, well, is it working fine now? They're going to say, sure. And they're going to say, okay, well, let's just leave it then. So.
Yeah, that is a prime example of the if it ain't broke, don't fix it, which is a testament to how solid V5 is, which is great. But I'm sure there's many, many advantages. So if anybody is out there with V5, it's been deployed, it's on the edge, etc. Should they would you recommend them checking out the website to see what some of the upgrade advantages are?
Definitely, I definitely recommend they check it out. But unfortunately, one of the things is that we did not make them interoperable, and we did that on purpose though, because we wanted. So I spent this month just kind of brainstorming the V8 usage, and that ended up being different than what it had for V5. But that's a good thing. But it also means if you're using V5, you can't just kind of use the same commands on a V8 model. It's going to be different. It's simpler, but it's different. Right. And so there is a bit of a hurdle to transition there. I'd say it's worth it over time. So I'm assuming, and I'd hope eventually most of the usage is going to migrate over to V8. And also, I should say another thing. So V8 is a simple architecture, but it's been implemented in the Ultralytics /Ultralytics GitHub repo, which is itself a framework capable of supporting many different architectures. And so we don't just support V8, we also support many other models, including inference with models like made as SAM, some other versions like FastSAM, YOLO NAS, and RT Debtor, which came out of Baidu, and so on. And so the architecture that we have there is just one of many, but it's really implemented in a scalable framework that is the future for us, and that we're going to continue to build on.
Fantastic. Well, yeah, nobody's sleeping here. Watch this space. Right, Talia, what do we got next?
So what technical factors are crucial for deploying projects on edge devices with YOLO V8?
Yeah, so I would say anybody that's considering an edge deployment in a solution should take a step back and consider everything in context. And so, for example, if you want to deploy, say, a sports app, you should look at the available hardware, not just present, but for example, older devices. If you want to deploy in other parts of the world, users may have devices that are out of date, different operating systems, and so on. And so the AI model is just simply one link in a chain. And so a lot of people really focus on things like performance metrics, like an export pipeline, but you also want to consider how that fits into your product. For example, let's say you have a video solution, and you know that this tracker that we have is not infallible. Like every once in a while, it might drop a frame, miss a person, and you need to be able to create a product that's robust to those possibilities. So I would say that in Edge in particular, you also want to be very cognizant of the limitations of the hardware that you're deploying to. So if you, for example, have low power devices, if this is going to be deployed on a battery or something like that, the power draw, if this is, say, in a factory, the thermal effect on the room that it's in, maybe cooling solutions where it needs to get deployed. There's so many different considerations that need to come into play. This is, of course, one of the reasons that AI is so interesting to us. It's because it's not a solved problem. If it was just trivial, people would just sort of take a look and say, wow, that's great, it works really well, but let me go find some other challenge in my life. So,
yeah, it's not for the faint of heart. Let's put it that way. Excellent. Talia, do we have more questions from our wonderful online community?
Yes. Are you considering multimodality for future versions of YOLO?
Let's see. So if by multimodality, I think you mean different task support, then yeah. So as I referred to in my earlier question, I think utilization of a common backbone, recycling those flops, and training on different data sets at the same time for a more kind of generalized, robust model, I think is definitely one option. I don't think it's not for everybody, because a lot of the benefit of YOLO is that it's so specialized to a single use case that it's really the most efficient solution you can have. And I think, adding additional tasks, adding additional modalities, making it more flexible, I think serves a significant part of the market. And it's something that we don't serve right now. So yeah, what we do is we don't actually guide the roadmap ourselves for the most part. Like usually this is guided by the community. It's guided by what we see people complaining about, features that they're asking for. This is an ongoing conversation that we have. And when we see kind of a need pop up that we're not addressing, and we see many people mention it, then we start to prioritize it. So,
yes, watch this space. Okay, Talia, do we have more questions?
Do you have plans to add YOLOv5 to Python Ultralytics package?
oh yeah, okay. So this is interesting. Let's see. So as I mentioned, YOLOv5 had a completely different set of modules, completely different interface. And so, initially I looked at this and I said, okay, this is just, it doesn't make any sense for like one company to launch a follow-on product that's completely incompatible with the first product. It'd be like if Apple launched an iPhone with a different plug than last year. So, okay, but but let's see. So, okay, so what we did is we had this compromise, and so there are these models in the Ultralytics Python package. And so what we can do though is, so we can use the YOLOv5 YAMLs, which design the model, but the difference is that we have a common set of loss functions, visualization functions, data loaders, and heads that are shared across a variety of different architectures. And so the Ultralytics Python package has modified YOLOv3 models. It has modified YOLOv6 models, modified YOLOv5 models, and the official YOLOv8 models. And so it has a type of YOLOv5 model inside it. It's called YOLOv5U, and the U stands for Ultralytics. And the performance of the V5U models is about 80% of the way between a YOLOv5 model and a YOLOv8 model. The only difference is the head, but it turns out the head has a big part to play. So the head that we have in the YOLOv8 model is substantially different. We were inspired by YOLOx, by the split head. We also have a completely different box loss function that uses DFL, so it does many different boxes and creates a weighted combination. We've also gotten rid of the objectness loss to simplify things, and we've reweighted the hyperparameters. And as a result of this, the head plays like an outsized part in the architecture itself. So in a nutshell, yes, there's a type of YOLOv5 model available from the Python package. It's got everything identical to the YOLOv5 repo models, just a different head, and it provides about 80% of the performance improvement of a YOLOv8 model.
Tremendous. What brilliant questions we have. Talia, what say you?
So that is actually it.
Okay, phenomenal. Well, to quote somebody, I don't know who said this first, but an army marches on his stomach, so we are going to break for lunch now, but not before giving a huge round of applause to the founder and CEO of Ultralytics, Glenn Jocher. Thank you.